In this lesson, we'll be looking at the graphical representation of the solution to a system of two equations and solve systems of two equations by graphing. So let's think about the solution to a system of two equations graphically. These linear equations in two variables are equations of lines. Two lines can do one of three things. They can intersect at a single point, never intersect, or totally overlap each other. The solutions to a system of two linear equations is the points where the two lines intersect. So let's look at these three situations. Intersecting at a single point. This system will have one solution, and that single solution will be at the point of intersection, right here. If the lines never intersect, and we know the solution to a system is the point where they do intersect, if they never intersect, then there's going to be no solution. These lines are parallel to each other. And the last case is when the two lines totally overlap each other. These lines are going to intersect over and over and over and over again. In fact, there will be an infinite number of solutions. Let's solve some systems by graphing. What we're going to want to do is write each equation in slope-intercept form. Then we can check for the number of solutions we're going to have. If the two lines are exactly the same, the two equations are the same, then we'll know right away that there's an infinite number of solutions. If the two lines have the same slope, but a different y-intercept, we'll know right away, without graphing, that there's no solution because the two lines are parallel. If it's not either of those two situations, the lines will intersect at a single point. We'll graph the two lines to find that point of intersection. So let's start by writing our equations in slope-intercept form. I'll subtract 2x over, giving me negative y equals negative 2x plus 1, and then divide each term by negative 1, giving me the equation y equals 2x minus 1. Solve our other equation for y. All I need to do here is subtract x over. We get y to be equal to negative x plus 5. Well, now I want to compare these two equations. Are they exactly the same? No, so it won't be an infinite number of solutions. Do these two lines have the same slope? No, they don't. So it won't be no solution because the lines aren't parallel. This means that these two lines are going to intersect at some point, and we need to graph the two lines to find that point of intersection. I'll start by graphing y equals 2x minus 1. This has a y-intercept of 0, negative 1, and then a slope of positive 2. So we're going up 2 to the right 2. When I'm solving by graphing, I typically make more points when I'm drawing my line than I normally do because I'm hoping that these two lines are going to intersect at one of these points, and it's going to be very obvious to me. Now we'll graph y equals negative x plus 5. This line has a y-intercept of 0, 5. And a slope of negative 1. So I'm going to go down 1 to the right 1, down 1 to the right 1. And I draw on my line. My solution is going to be my point of intersection right there. How do we get the ordered pair? Just look at it and count over from the origin. That's 2 to the right and up 3. The solution to our system is the ordered pair 2, 3. Let's try another one. The first thing we want to do is rewrite our equations in slope-intercept form. I'll start with negative x plus 3y equals 9. I'll add x over, and then divide each term by 3. This is going to give me y equals 1/3 x plus 3. My other equation is already written in slope-intercept form. Now I want to take a look at my two equations and determine the number of solutions I'm going to have. Do I have the exact same equation twice? No, so it won't be an infinite number of solutions. Do my equations have the same slope? Yes, they do. They both have a slope of 1/3. This tells me that these lines are parallel. Parallel lines never intersect. Therefore, there is no solution to this system.